Okay, now let's solve numerical number 3. Now what they have given? An impulse turbine has a mean blade speed of 200 meter per second. Okay, so this is value for U. The nozzles are inclined at an angle of 20 degrees. That means value for alpha is 20 degree. The steam velocity from the nozzle is 600 meter per second. So this is nothing but my value for V1. The turbine uses 3500 kg per hour of steam. So this is my mass flow rate. The absolute velocity at exit is along the axis of the turbine. So this is very important statement. Okay, now what does it stand for? Our discharge is axial. Now what we need to calculate? We need to calculate diagram efficiency, axial thrust, power produced, assuming symmetrical blades. Symmetrical blades means what? The value for theta and phi will be equal, correct? Now as we have just discussed in the earlier problem, as a discharge is axial, my value for V2, okay, will be overlapping on VF2 because this is the flow velocity which is indicating the axial discharge. Okay, that's why that V2 will be overlapping on VF2, and as a result of which beta will be 90 and your value for VW2 will be 0. Correct? Now let's solve the numerical further. So these are the given things. Okay, they have given mass flow rate in terms of kg per hour, so I will convert in terms of kg per second. Okay, discharge axial, that's why these are the necessary things that we need to keep in mind. And as the blades are symmetrical, theta and phi will be equal, correct? So these are the things which we need to calculate, that is diagram efficiency and axial thrust. Okay, now from this particular diagram, okay, we have shown beta is 90 degrees. So let's understand what is the formula for diagram efficiency. So we know very clearly it is VW1 plus VW2 into U upon V1 square and twice of this particular case, correct? Now as the discharge is axial, VW2 is automatically going to be 0. So the formula will be only in terms of VW1, U and V1 square. Out of that, V1 and U are already given. So you can see over here, V1 and U are already given. So our main target is to find out this VW1. Now, again, I'm considering this particular triangle. Okay. So if I apply formula for cos alpha, it will be what? Adjacent side upon hypotenuse. Okay. Alpha is 20 degree. They have given in the problem only. Okay. VW1 is unknown that we need to calculate, and V1 is again in the given. So from this, we will get value for VW1. I'll put the value in this particular formula. Okay, I'll simplify it and automatically I'm getting the answer for blade efficiency, also called as diagram efficiency, which is nothing but 62.64%. Now we need to calculate axial thrust. Now as we have studied in the theory part, we have discussed about tangential thrust. Tangential thrust is basically because of the whirl velocity. Okay, as this tangential force is acting on the rotor, your blades are getting rotated, creating whirl. That's why tangential force is responsible with whirl velocity. Okay, now why this plus sign? Because we have already discussed VW1 and VW2 both are in opposite direction. That's why minus of VW2 will become plus. Now whenever I talk about axial thrust is responsible, or it is related with flow velocity. Okay, so you can see m dot Vf1 minus Vf2 into U, correct? Now why this minus sign? Because we already know whenever I talk about minus sign, okay, this minus sign is because Vf1 and Vf2 are both in same direction, correct? Now here if you can see, if we simplify this by applying formula for sine alpha from this particular triangle, we will get value for Vf1, as alpha is 20 degree, V1 is given. Okay, so we will get value for Vf1, which is over here. Okay, now we need to calculate value for what? The next case, which is nothing but phi. Okay, now as the value for V2 and Vf2 are same, okay, and theta and phi are equal, so let's find out value for theta first. So that theta will be automatically going to equal with phi. Okay, so now if I apply formula for tan theta in this particular triangle CDE, it will be what? It will be Vf1, which is opposite side upon CD, which is my adjacent side to this theta. Okay, this CD can be written as what? It will be VW1 minus this U. So that I have shown over here. Okay, value for Vf1 we have just calculated earlier. VW1 we also know it. U they have given in the problem only. So from this I'll get value for theta, which is 29.42 degree, which is automatically going to equal with 5. Okay, now our target is to find out what? VR1. Why VR1? Because from this theta, okay, if we calculate VR1, okay, it will be easier for us for the next calculations. So if I apply formula for cos theta, it will be what? CD, which is adjacent side, upon hypotenuse, which is what? VR1. Okay, so theta we have just calculated from here, CD we have calculated earlier, okay, over here. Okay, so VR1 will be what? 417.67 meter per second. Now let's calculate VF2. Okay, so this is my outlet triangle, outlet velocity diagram. Okay, so tan phi will be what? It will be opposite side upon adjacent side. So this V2 is nothing but what? VF2, which I have written over here. Okay, so let's calculate tan phi. Phi is nothing but theta, that's why both values of theta and phi will be same. U is given. From this we will calculate value for what? VF2. Okay, now the formula for this particular axial force, okay, as we have discussed earlier, it is m dot into bracket what? VF1 minus VF2. Okay, just take a note of this, just necessary correction. This U is not here. The formula is what? Only m dot into bracket VW1 plus VW2 for tangential thrust, and for axial thrust it is m dot into VF1 minus VF2. Just ignore this U in the axial thrust and tangential thrust. Okay. Okay, so with that note, if we simplify this, VF1 and VF2 we have already calculated. So this FA will be what? 89.854. Kindly make a correction. U is not here. That was the clerical mistake in the PPT. So please make sure of it. Okay. Now we need to calculate value for power developed. Now we know the formula for power is what? M dot into bracket VW1 plus VW2 into U upon 1000. As the discharge is axial, this VW2 will be 0. We have calculated value for VW1. This mass flow rate is in kg per second, as we have divided by 3600, so that it will be into kg per second. This U is given in the problem only. So if you simplify this, your value for power will be 109.62 kilowatt. Okay, so I hope you have understood the problem. Kindly repeat the videos for better understanding. Once again I am reminding, for axial thrust and tangential thrust, do not consider U over here. That is the clerical mistake in the PPT. Okay, thank you so much.